Shivani is an ecologist and a climate change researcher. Ranjan is an ornithologist and an expert in bird populations. They are meeting interns Nikhila and Abhishek to educate them about their project and assign tasks to collect bird data for their project, which is identifying birds and in turn their populations.
Hi Nikila, hi Abhishek.
Hi.
Hi.
Hey guys.
Hi. So we have a very interesting upcoming project that requires a little bit of work in the forest region. So the field work is very important from the perspective of figuring out how our restoration projects are doing. Specifically, we want to monitor the change in the biodiversity from the climate change perspective.
So yeah, I can take off from here. So as we all know, the population count of birds holds significant importance when we try to assess the overall health of biodiversity. This is because birds as a species are very sensitive to climate change. Therefore, we view this project as a valuable opportunity to explore and evaluate various effective methods for identifying bird species within the forest. Shivani, can you take over?
Yeah. So right now we can think of two ways to figure out the population or the diversity of the birds. To classify, we can either use capturing the videos a method, or we can go by capturing the audio method. So Nikhila, I'd like you to work on the capturing of the videos part to figure out the diversity or classification of the birds that we plan to do.
And yeah, Abhishek, it would be your responsibility to identify bird species by collecting their audio samples from the forest.
Great. Do you guys have any questions for us?
No question from my side.
Okay,
No,
cool.
all the best, guys.
Let's get started.
Intern Abhishek and intern Nikhila go to the forest to collect audio and visual data. We infer that cameras are more expensive. We also require multiple cameras to have high coverage for particular area. It's also noted that a bird in movement might not be captured properly in the video. The collected bird audio is quite clear. From this we infer that audio recording offers higher coverage, is less expensive, more robust, and hence a good method for collecting bird data. It's time to process the collected data. Our goal is to train an ML model to identify birds and also participate in the BirdCliff 2023 competition on Kaggle. The bird recordings for the competition were collected in the forests of Kenya. After collecting both audio and visual data, we inferred that audio data is more effective for our purpose. A given audio might not contain bird calls throughout. A bird call might be present at only certain time frames. We used PHA TweetyNet that was developed by engineers for exploration at UC San Diego to extract 5-second audio chunks where bird calls are present. We converted these chunks to MEL spectrograms. We use these MEL spectrograms to train various ML models. As the performance of VGG16 was the best, we trained the VGG16 model to classify birds. We took a 5-second audio chunk, converted it to a MEL spectrogram, and used our trained model to appropriately identify birds. We used several data augmentation techniques to improve the performance and generalize our model. Some of the techniques were frequency masking, time stretch, etc. Our Kaggle BirdCliff 2023 submission results are tabulated here with the model, data augmentation technique, and public and private scores. The public score is on 30% of the dataset, and the private score is on 100% of the dataset.